My name is Raja Mehra. I have been dealing and developing the emulsions over the last 20 years. For me, the emulsion technology is not a science purely, it is an art. Over the last 2 decades, I have developed a very strong understanding of this technology through continuous research and development, and I have created products as well as the fundamentals to create tailor-made products for various screen printing applications. Here today, I would like to share with you what exactly this technology is all about, and I would like to throw some light on the dual cure photopolymer chemistry. The diazo dual cure photopolymer emulsion basically is a direct emulsion, and it is based on the latest dual cure photo curing chemistry. This system incorporates all the processing features of a diazo sensitizer coupled with the advantages of a photopolymer to produce a screen of the highest quality. The ready-made stencil can be later on post-hardened by light to increase the resistance against solvent-based inks and has excellent chemical resistance to solvent, UV, water-based, and for graphic, ceramic as well as textile printing applications. Here we are able to create products in the range of 25% up to 50% solid content as per the printing requirement. We can have the ink suitability which can be built in the photopolymer emulsion as such as resistance to water based inks, solvent based inks, UV inks, for graphic printing, for textile printing, for ceramic printing, and for PCB electronic printing. What we are looking out here is we are looking at different type of emulsions as shown in the pyramid. Here we have the lower end emulsions, the first row of emulsions, which are basically in the range of 25% solid content. Here we are using the diazo dual cure chemistry to create products which are having different solvent resistance, like 369 is a solvent and UV ink resistant emulsion. It's also resistant to plastisols. It can be used in textile, in graphics as well as in ceramics. It has a short printing life, but it has very good imaging capability. Then we go on to make another product, that is a WR9 Plus, which is a water resistant dual cure photopolymer emulsions. Here the solid content is in the range of 35%. It is very good for textile printing and garment printing. Then we have another product called Rapoline 169, which is again a solvent and UV ink resistant emulsion, but here the solid content is in the range of 25%, but at the same time it has a very good reclaimability, much better than the earlier emulsions. We go on to another level of emulsion by increasing the solid content of the emulsion and creating the band of different ink suitability, increasing the band of different ink suitability to a much higher degree, where we create an emulsion which is a universal emulsion, which is resistant to solvent, water, UV ink, and a variety of other ink systems. We have Rapoline 269, which is a purely universal emulsion. The solid content is in the range of 38%. We have another emulsion called Rapoline 769, which is again a solvent and UV ink resistant emulsion, but it is a dual cure emulsion, having a solid content in the range of 38%. Then we have another emulsion called Rapoline 569, which is again very good emulsion for graphic industry, for electronics, and even for ceramic porcelain industry. It is having a solid content of 35%. Further on we move on to another emulsion which is even of a much higher solid content, Rappoline 669. This emulsion has a solid content of 50%. It is a maximum resistance emulsion to all textile printing ink systems, where if you're using water-based inks, plastisols, even solvent inks to a degree, and discharge inks, which are acid-based inks. So this emulsion is highly resistant for long printing runs and a very high solid content emulsion where even you can create high density screens up to 200 microns. For the emulsions, for the emulsion selection, there are two very important criteria we must understand. In order to create an emulsion which can cover two aspects of printing, screen printing, one is you need a very good reproduction of the artwork, not only on the screen but also on the printed substrate. You also need enough of ink deposition to give, for example, if you're printing on a ceramic porcelain, first the printing is done on a transfer sheet. Even in textile transfers, first the printing is done on a transfer sheet and then it is water slide or heat transferred onto the substrate in textiles. In this case, you need a minimum deposition of the ink for the print to become more visual. So the solid content of the emulsion here, along with the viscosity and the photopolymer content, plays a very critical role coupled with the diazosensitizer to give the correct resolution and definition you need to get the complete artwork onto your substrate, due to the most important feature in this dual cure chemistry, which is that it has a very wide exposure latitude. So high solid content and wide exposure latitude, these two criteria play a very important role in giving a bright color picture, a very good reproduction of the artwork, and this is how you get a very high quality of printing through screen printing. Now we must understand that screen printing in itself is not an industry, it is a technology. And within screen printing, there are various technologies which are playing very critical roles. And the screen printers worldwide, whoever are using, even the best brands from US, Europe, or even Japan, they must understand what they are using, why they are using, and at what cost they are using. For this very reason, we have brought out this endeavor to share with you the in-depth of this technology, and we are being instrumental to have this closely held niche technology to reach the far corners of the world. If you would like to know more about this proprietary technology we have, kindly feel free to contact us at the below given details. Thank you.